question 3.1, we are told to consider the following geometric series. This is the geometric series given, and the first question says that for which values of x will the series converge? So whenever they ask you this, for which values of x, or for which values of r, whatever, will the series converge, you know convergence is determined by this. R must lie between -1 and 1. So this determines convergence of a series, a geometric series rather. So for us to prove this convergence, we must find R in this geometric series. So to find R, we know it's going to be R equals to term number 2 divided by term number 1 is equals to term number 3 divided by term number 2. So this is term number 1, this is term number 2, this is term number 3, right? So R is equals to, our term number 2, it's 5 into 3x plus 1 whole squared. Our term number 1, it's 5 into 3x plus 1 equals to, so the terms must be, the ratios must be equal for us to confirm that that is actually the ratio we're looking for. So here it's to the power 3 over 5 into 3x plus 1 to the power 2. So if you can see here, this is similar to this, so they divide out, and these are similar only because this one is squared and this one is 1. So you'll remain with 3x plus 1. So this is going to be your R in both sides. So it's going to be 3x plus 1. So that is your ratio. So you're going to put your ratio inside this convergence here. So you're going to say my convergence must lie between -1 and 1. But what is my R? It's 3x plus 1. Lie between -1 and 1. -1 and 1. So for us to solve here, you must transpose this one both sides. So you transpose it that side, you also transpose it that side. So we're going to have -1 because they changed the sign from positive to negative, less than 3x, less than, so it's going to be the 1, which is this one here, and then -1. So you're going to have 3x less than, so this 1 minus 1 is going to give you 0, less than this -1 minus 1 is going to be -2. Divide by 3 both sides. You're going to have x lies between 0 because 0 divided by 3 is 0 and -2 over 3. So this is your convergence of series. This is your solution. X must lie between -2 over 3 and 0. So now 3.1.2, we want to calculate the sum to infinity of the series if x is equals to -1 over 6. So we want to find the sum to infinity. We know the sum to infinity equation. It's a over 1 minus r, right? But we know our r. Our r that we found in 3.1.1, it's 3x plus 1. So basically what's inside here, it's common ratio. We calculated it, didn't assume from the given series. So our r is equal to 3x plus 1, and we need to find our a. So our a is the first term of the series. So a in this case, it's this one here, which is 5 into 3x plus 1. So let's substitute this in our sum to infinity, because we are asked to find the sum to infinity. So when I say sum to infinity is equals to our a, which is 5 into 3x plus 1, divided by 1 minus our r, which is 3x plus 1. So this is 3. Cool. So now, but you need to remember that we were given that x is equals to -1 over 6. So meaning where we see x, we put -1 over 6. So, excuse me, so it's going to be 5 into 3 into -1 over 6 plus 1 close bracket over 1 minus into 3 into minus 1 over 6 plus 1, close bracket. So the answer that you're going to get here is going to be 5. So that is your sum to infinity. So now we are going to do 3.2, which we are asked to determine the smallest value of k such that the sum is greater than 30. So if you check, it's greater than 30. So the sum, which is this one here, is greater than 30. So we need to find that value of k. For us to find that value of k, we need to find our sequence first, our series, right? So to find our series, we are given the sum, p is equals to 1, 2 to the power p minus 4. So let's first find our series. So when p is equals to 1, because it's the starting point of our series, we're going to substitute 1, this 1 minus 4 is equals to 2 to the power minus 3. And then when p is equals to 2, it's 2 to the power of 2 minus 4, which is 2 to the power minus 2. When p is equals to 3, it's 2 to the power 3 minus 4, which is equals to 2 to the power minus 1. So now we have our series, which is 2 to the power minus 3 plus 2 to the power minus 2 plus 2 to the power minus 1. Someone wants to write it in fraction form. It's going to be 1 over 2 to the power 3 plus 1 over 2 to the power 2 plus 1 over 2. And someone can want to simplify it further. You 1 over 8 plus 1 over 4 plus 1 over 2. So this is your series, right? And we want to find the value of k. So for us to do that, let me eliminate the side used. So now we have our series. We want to find the value of k. So for us to find the value of k, we have to find the sum. We have to find the sum of k, right? We're already given that the sum is equals to 30. So the sum of k, because k stands for the number of terms, I assume it's at the top of the sum. I know that doesn't mean it's the number of terms in general sense. That k at the top doesn't mean the number of terms. So we're just gonna say s of k is equals to our a into 1 minus r to the power of k. Instead of writing n, divide by 1 minus r. Remember that the standard one is Sn is equals to a into 1 minus r to the power n. Let me remove this. Divide by 1 minus r. So this is the standard equation of a geometric series. So we're going to use this one. So where instead of writing n here, we're just going to write k. Cool. So the reason why we consider this k as n is because we're starting at p is equals to 1. So there won't be much effect because the number of terms, we find it by saying top minus bottom plus 1, of which the top is k, the bottom is 1 plus 1. So this cancel out, so n is equals to k. So that's how you can prove it, that actually k is equals to n. In this case, not all the time. So we're having our sequence here, which is this one here. We need to substitute. So our a value, which is this one here, it's actually equals to 1 over 8. Remember that this is our sequence, or our series rather. So our first term is 1 over 8, and this is a geometric sequence or geometric series. How do you prove that? You need to find the difference in ratios. So you're gonna divide to find the ratios of these. So you're gonna say r is equal to t2 over t1 equals to t3 over t2. If the ratios are the same, of which they are the same, I found 2 as my ratio. Therefore, this is a geometric series. So our r is equal to 2. So now we know our r. We don't know our k. And we know that s of k is equal to 30. It's not necessarily equal to 30. The sum must be greater than 30. Cool. So meaning here, you're just going to write 1 over 8 into 1 minus, our r is 2 to the power of k divided by 1 minus 2, it must be greater than 30. So that's what the question says. So we're going to simplify this out to find the value of k. So remember that is the whole point, to find the value of k, such that it gives you a sum greater than 30. So what you're going to do is this. You're going to say, so you're going to solve this bottom, 1 minus 2, which is minus 1. So that minus 1 will multiply, cross multiply. You're going to multiply this 30. So we're going to have 1 over 8 into 1 minus 2 to the power of k. It's greater than minus 30. Then you multiply by 8 both sides. And then 1 minus 2 to the power of k greater than 30 times 8. Transpose the 1 to the other side. You have minus 2 to the power of k greater than 30 times 8 minus 1. Right? Then your minus 2 to the power of k is greater than, if you do that problem, you're going to get minus 241. Right? So it's minus 241. So here, what you do, you're going to remove the negative, divide by negative 1, divide by negative 1, both sides. You have 2 to the power of k. Because you're dividing by negative, the sign will change. From greater than, it's going to be less than 241. Right? So now you're having your 2 to the power of k is less than 241. So you're going to use your logs. Right? So this is your base. So remember that log works like this. Log, our base is at the bottom, and then this is our variable equals to our exponent. So this is exponent, this is base, and this is just a variable. So we're going to say we're going to equate to the exponent. So our exponent is k less than our log of base, which is 2, and then our variable, or our value rather, it's equals to 241, just like that. So you're going to punch your calculator, so you're going to get k less than 7.9. so this would be the answer that you're going to get. So how you conclude is this, because you're not done. So you got k equals, you got k is less than 7.9. That's what you got as your answer, right? So what you need to do is you need to go back to the question. What does the question want? It wants solutions of k such that the sum will give you greater than 8. So for you to conclude from here, you can test. You can test in your sum formula, test for k it's greater than 7.9, for example. You can say k is equals to 7 and see if it's going to give you a sum that is greater than 30. So what do I mean? You have your sum formula, which is equals to a into 1 minus r to the power of k over 1 minus r, and we said this is 1 over 8 into 1 minus 2 to the power of k over 1 minus 2. So you can test it in this formula here. Put your value of k here. Of k is equals to maybe 7, and see if it's going to give you a value that is greater than 30 here, which is what's required basically. So if it doesn't, which means your k value must be greater than that one. Like you can test 7.9, and see if it's going to give you a value that is greater than 30. If it doesn't, which means you're looking for a greater value than 7.9, which is the case. So if you say k is equals to 8, it will definitely give you a value or a sum that is greater than 30. So this would be your final solution of k. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.